Hello students, today going to start the second chapter of physical chemistry is chemical equilibrium. In last first chapter, chemical energetic, we saw the different concepts of thermodynamics. Basically we seen there is a definition of first law of thermodynamics, second law of thermodynamics, and there is a number of energies which are involved during the chemical processes. So again we discuss the third law. So today going to start the next point is chemical equilibrium. So the meaning of equilibrium means it reaches the when reaction is carried out from reactant to product. That time there is a change in state, initial state to final state, means from reactant side to product side. How equilibrium is balanced means how equilibrium is shifted in the form of concentration, in the form of energy, in the form of heat and all the things. So when any reaction is happen, then formation of product. So that time how product is formed. So what happen when product is formed? Energy is introduced or energy is evolved. So it depends on nature of reaction and nature of reactant, means how reactant itself has the energy. म्हणजे रिॲक्टंटकडे कोणत्या एनर्जीज अवेलेबल असतील त्याच्यावर डिपेंड करतं की ज्यावेळेस प्रोडक्टमध्ये कन्वर्ट होईल त्यावेळेस ज्यावेळेस इक्विलिब्रियम जे असेल इनिशियल ते ज्यावेळेस फायनल म्हणजे प्रोडक्ट फॉर्म होईल त्यावेळेस शिफ्ट होईल, त्यावेळेस एनर्जीचं ट्रान्सफॉर्मेशन जे होणार आहे त्याला आपण म्हणणार आहे केमिकल इक्विलिब्रियम. म्हणजे केमिकल ट्रान्सफॉर्मेशन ज्यावेळेस होणार आहे रिॲक्टंट टू प्रोडक्ट. सो वी गोइंग टू डिस्कस इट इन गिवन चॅप्टर. So in introduction, so second law of thermodynamics is introduced. The important function is entropy. Basically entropy is the randomness of the system. So any order which after it converts into disorder, we say there is a change in entropy. So always in a spontaneous process, in a irreversible process or in a natural process, entropy always positive. Okay, it is according to second law of thermodynamics. But third law says entropy will be zero when the substance is perfectly crystalline and temperature is absolutely zero. But suppose any spontaneous process, any natural process is proceed, that time entropy will be positive, it is greater than zero. So the criterion which is used involved in spontaneous processes is always delta S is greater than 0. That means change in entropy always greater than 0 in a spontaneous processes. But the thermodynamic concept introduce the another function is Gibbs free energy. So Gibbs free energy is equal to H minus Ts. H is the enthalpy, T is the temperature and S is the entropy. Okay, so G means Gibbs free energy. So what is the meaning of free energy? Free energy means the energy which cannot be used to do the work. It is the excess energy which is present in a system, but the energy which is not useful to do the work. Means suppose reactant has their free energy, we said Gibbs free energy, the energy is available, but this is the internal energy, but it is not useful. Energy use होत नाही प्रोडक्ट फॉर्मेशन करण्यासाठी, त्याला आपण गिब्स फ्री एनर्जी म्हणतो. सो अकॉर्डिंग टू इट चेंजिंग गिब्स फ्री एनर्जी इज इक्वल टू the heat, the enthalpy which is present minus T into delta S. That means it is the first equation, G is equal to H minus Ts, means H is the enthalpy minus temperature into entropy. The result is, because बघा समजून घ्या की एंट्रॉपी काय आहे की ही रँडमनेस आहे, एक्सेसनेस आहे जी एनर्जी वर्कमध्ये यूज केली गेलेली नाही आहे. सो एंट्रॉपी विच इज नॉट यूज इन वर्क, एनर्जी विच इज नॉट इन वर्क त्याला आपण एंट्रॉपी म्हणणार. एन्थॅल्पी म्हणजे काय, ॲक्च्युअल ती एनर्जी यूज होते, युटिलाइज होते. मग समटाइम इन द फॉर्म ऑफ प्रोडक्ट, समटाइम इव्हॉल्व ड्युरिंग द रिॲक्शन or sometime enter in the reaction, it is a heat content. Okay, heat of the system, heat of the reaction, त्याला आपण म्हणतो एन्थॅल्पी. मग जी टोटल हीट असेल तिच्यामधनं जे टेम्परेचर प्रोव्हाइड केलेलं असेल इनटू जी एन्ट्रॉपी, जी एक्सेस एनर्जी डेव्हलप झाली असेल ती मायनस केल्यानंतर, म्हणजे एन्थॅल्पी म्हणजे वर्क टोटल एनर्जी होती तिच्यामधनं टेम्परेचर त्या सिस्टीमचं ॲज वेल ॲज जी एक्सेस एनर्जी आहे जी वर्कमध्ये युजफुल होत नाही जे एक्सेस एनर्जी अवेलेबल असते ती मायनस केली, जो रिमेनिंग असेल त्याला म्हणतात फ्री एनर्जी. ती असणार आहे फ्री एनर्जी. एंट्रॉपी इज द सोर्स ऑफ एनर्जी. Enthalpy, which is actually available to do the work, to do the process. Temperature, which is provided. Apart from this all, if some energy is available, some energy is remaining, that energy called as Gibbs free energy. We are going to discuss this function in today's lecture, as well as in that chapter totally based on the entropy as well as the Gibbs free energies. So the new criterion which is introduced is 0 is greater than delta G. Delta G is the change in entropy. How we calculate? Delta H minus T delta S. It is the second equation. Using this equation we can calculate change in entropy, change in Gibbs free energy. And how Gibbs free energy is calculated? G is equal to H minus T S. H is the enthalpy, T is the temperature, S is the entropy. Okay, so the change is calculated using this equation. So new criterion is introduced. It is a delta G is less than 0. So we are going to discuss the Gibbs free energy, which is new function of thermodynamics, in detail. So basically the criterion used to understand the chemical equilibrium is Gibbs free energy, which is involved during the chemical reaction. For example, if we consider A plus B gives C plus D. Okay, so here A is B, small c and D. So here AB is the reactant, CD is the product, and small ab and small cd are the coefficients of that reactant and product. Okay, suppose we are going to calculate delta G. So first of all we must know the Gibbs free energy of the individual reactant. Means here we consider the free energy of A, free energy of B, free energy of C, free energy of D. So we can calculate delta G, how it. So there is a reactant, there is a product. Means we calculate A into G of C minus, plus D G of D minus. So here is a product minus, what is the reactant side? Here is the A, G, A plus B, G, B. So here is the reactant. So basically change in free energy calculated, the sum of the free energies of the reactant minus, sum of the free energies of product minus sum of the free energies of reactant, we get the delta G. This equation we represent in another form. That means delta G is equal to, so here is a reactant, so sum of NP, okay, G, then G of which there is a product minus sum of NR G of reactant. That means what? The sum of Gibbs free energy of product minus sum of Gibbs free energy of reactant. Basically here NP and NR is the number of moles of product and number of moles of reactant. So we can use this. Sometimes the energy which is converted in the molar Gibbs free energy. Suppose we consider molar Gibbs free energy, so we can write this equation as sum NP Gm product minus NR Gm reactant. Means here the free energy which is considered as a molar Gibbs free energy. Here just free energy. Sometimes the Gibbs free energy is measured in a standard state. So in standard state we can also calculate changing free energy, how it. So if we consider delta G naught is equal to, so it is a standard state. Again we use same equation. So summation of NP G M means molar Gibbs free energy Gm naught of product minus summation of Nr Gm naught of reactant. So we can use this summation of number of moles of product into standard molar Gibbs free energy of product minus summation of standard molar Gibbs free energy of reactant. So using this we can calculate change in free energy. So if we are going to calculate this condition is given is a standard state, that time we consider standard Gibbs free energy, and other than standard state we just consider if molar condition is there, so molar Gibbs free energy we consider or just Gibbs free energy is considered depending on the condition. So there is a equation, if we consider this is the equation number 3. First equation is second equation, the third equation is this one. So fourth equation consider this is the fourth equation. Okay, then here is the fifth equation. So all equations are same. In all equations we find the change in Gibbs free energy. So the free energy which is given in which condition, either in normal condition, either given in standard condition, then we decide which formula to be considered for to find the change in free energy. Okay, so after that if condition is standard state, then this gives free energy, suppose when reactant converts into product. So there is a formation, some heat is there, gives free energy. So when there is a reactant converts into product, so there is a formation of product. So that time we called this Gibbs free energy is the standard Gibbs free energy formation. So standard Gibbs free energy formation, so that time we calculate delta G naught F. F means formation. So standard Gibbs free energy formation is equal to summation of NP Gibbs G F G naught F of product minus summation of NR G naught F of reactant. So again it is the same thing. Here is a molar Gibbs free energy is considered, here Gibbs free energy formation is considered. So in Gibbs free energy in any condition we can calculate using this. So basically we must know the change in free energy is calculated, but we already know the delta G is equal to delta H minus T delta S. So already we have this equation. So this is an important equation, this is the main equation because these are the conditions. So if reaction converts into product, means reactant converts into product, that time there is a formation energies exist. So we consider the Gibbs free energy of formation. So we consider standard Gibbs free energy of formation. So if we consider this equation, so overall delta G of formation is equal to, so there is a delta H naught F means enthalpy, standard enthalpy of formation minus T delta naught S F. So this is an important equation. Delta G naught F means there is a change in Gibbs standard Gibbs free energy of formation is equal to standard enthalpy of formation minus T standard entropy of formation. So there are two important things are required, enthalpy of formation and entropy of formation. Once we have the values of enthalpy of formation and entropy of formation, we can easily calculate the Gibbs free energy of formation. So this is the first about the Gibbs free energy. After that, there are two processes are introduced in chemical reactions. There are exogonic and, so there are important point is exogonic and endogonic process or reaction. Basically, you already know in thermodynamics two terms are used, exothermic and endothermic. But here exogonic and endogonic reactions means what? If delta G is positive or delta G is negative. So basically if delta standard gives free energy is positive and second condition is standard gives free energy is negative. Okay. Suppose it is positive, that time we say there is a exogonic reaction, and when there is a negative, sorry, it is vice versa. When there is a positive, we say it is a endogonic, and when there is a negative means it is a exogonic. So there are two reactions, endogonic and exogonic reactions are considered. For examples, the examples are given. Suppose formation of water. So formation of water means H2 plus 1 half O2 gives H2O is the negative type. When what is the positive type example? Formation of diamond from the graphite. So diamond formation from graphite, that time delta G is positive, and when there is a formation of water from H2 and O2 means H2 plus 1 half O2 gives H2O, that time the delta G is negative. So formation of water from H2 and O2 is considered as a exogonic reaction, and formation of diamond from graphite is considered as a endogonic reaction. So this is all about the exogonic and endogonic reactions. Gives free energy, basically gives free energy, or free energy means the excess energy which is available but cannot use as a source of energy or cannot use for the to do the work to complete the or to accomplish the reaction. So the energy which is remains in the reactant as well as in a product. So overall in reaction, how changing gives free energy, we will calculate using different methods. So in next leg point, we are going to discuss some problem which is based on this concept. So let us see the problem which is based on Gibbs free energy, how to calculate Gibbs free energy to giving from given data which is given in problems. Okay, the first problem which is based on Gibbs free energy means how to calculate Gibbs free energy using given data. I already told you what is the Gibbs free energy, how to calculate. We already know delta G is equal to delta H minus T delta S. Okay, so it is a normal Gibbs free energy. Suppose Gibbs free energy consider in a standard. So here calculate the standard Gibbs free energy of formation. Means here we are going to calculate standard Gibbs free energy of formation. Delta GF naught means standard Gibbs free energy of formation is equal to, so condition is standard means standard state is given, so the enthalpy and entropy also consider in a standard. So in problem what says, calculate the standard Gibbs free energy of formation of HI at 25 degrees Celsius from its standard molar entropies and standard enthalpy of formations are delta SF means standard entropy of formation is given and standard enthalpy of formation is given. So these two values are given, means from these two values how to calculate the standard Gibbs free energy of formation. So it is considered as a delta H naught F minus T delta S naught F. So using this formula we can calculate the Gibbs free energy of formation, means standard Gibbs free energy of formation. We have these values. So just we put the values. So here temperature it is given 25 degrees Celsius. We convert into Kelvin by adding the 273. So it converts into 290 Kelvin, 98 Kelvin. So just put the values here. So it is equal to, it is how much? It is a 26.48 minus, then what is the temperature? 298 is the temperature. Okay, so what is the temperature? 298 into, then the value is given 0.0832. So the answer is 1.69 kilojoule per mole. Okay, so first multiply these two and subtract from this, so we get the answer 1.69 kilojoule per mole is the standard Gibbs free energy of formation. So this way we can calculate. So it is the first method to calculate the Gibbs free energy when we know the values of delta HF means heat of formation of, as well as there is a entropy of formation. If we know the entropy of formation and enthalpy of formation, we can easily calculate the चेंज इन गिब्स फ्री एनर्जी ऑफ फॉर्मेशन असेल किंवा स्टँडर्ड असेल, दोघंपैकी कोणतीही आपण काढू शकतो जसं व्हॅल्यूज दिलेली असतील त्या पद्धतीने. सो ही फर्स्ट मेथड आहे की ह्या दोघं व्हॅल्यूज माहिती असतील तर आपण गिब्स फ्री एनर्जी काढू शकतो. वी गोइंग टू डिस्कस द अनदर मेथड टू कॅल्क्युलेट द गिब्स फ्री एनर्जी अँड द प्रॉब्लेम इज okay. The second problem is given to you. Calculate the standard Gibbs free energy change for the following reaction from the data provided. The reaction is given to you. Twice SO2 plus O2 gives twice SO3. So there is oxidation of sulfur dioxide into converts into sulfur trioxide. The temperature is given 25 degrees Celsius and the pressure is 1 bar pressure. And the data is given here. There are three substances, SO2, O2 and SO3. SO2, O2, SO3, and there is a heat of formation, means enthalpy of formation is given. For SO2 is 297, SO3 is 396, and you know the enthalpy of formation of molecular form is always 0. So for O2 it will be the 0, and the entropies are given, standard entropies are given. It is a 248, 257 and 205.